The important one is called the triangle inequality. We would have covered it a long time ago, but we don't have enough information to make it work. So, let's talk about the angles of a triangle. What do you know about the angles of a triangle? Right. They always add up to 180, and if they don't add up to 180, then you ain't got a triangle. There is a similar relationship in a triangle dealing with the sides. Common mistake that people make, and I see this all the time, is you want to add up the three sides of a triangle and set them equal to 180. And you laugh, ha ha ha, that's silly, but it happens all the time. That's not the triangle inequality. The triangle inequality says that if you take the two shortest sides, I'll write this down. The sum of the two shortest sides in a triangle, shortest sides in a triangle, must be greater than the third side. If they're not, you don't have a triangle. Michael, lose the iPad, you don't need it.
I'm trying to submit the thing. So
Oh, I understand.
yeah, I just powered it on.
We have three scenarios. Scenario number one, a triangle. For instance, 5, 7, and 10. How do I know that's a triangle? Because 5 plus 7 is 12, which is greater than 10. We'll call this scenario I. I'm kidding, that's a 1. Scenario number 2. 10, 2, 3. No triangle. Because 2 plus 3 is 5, which is not greater than 10. You just got those two little guys flapping in the breeze. Scenario number 3. 3, 7, 10. Triangle?
No.
No. The difference being, however, is that that third case will collapse into one segment. Notice in case number 2, the two sides will never touch. In case number 3, they will touch eventually, but not until it collapses into one 10-unit segment. Okay? This adds a whole nother problem for you guys, because from now on, you're going to need to take 2 seconds to check to make sure that you're actually talking about a triangle. Because some jerk teacher of yours would give you a big long problem involving 3 sides of a triangle, and it turns out it won't be a triangle. I'm just saying, it could happen. Okay, so spend the time and check to make sure that you have a triangle first, and then go from there. Okay, so, a couple silly examples here. Ooh, that green is not so good. Let's use blue. 8, 15, 17. Triangle?
Yes.
Yes. 14, 6, 8.
Yes.
Triangle?
No.
No. 5, 5, 12. What kind of triangle, by the way? No. Suckers. No triangle. 5 plus 5 is 10, which is not greater than 12. Totally fished in. Easy?
Yes.
All right. Not so easy is the following. Suppose I have
What if you have angles?
2 sides of a triangle. What are the possible side lengths for the third side of the triangle?
13.
Greater than.
Michael.
Any real number greater than 13.
Any real number greater than 13, excellent, because 5 plus 7 is 12, so it's got to be greater than that, right?
Greater than 12, sorry.
Greater than
12.
12.
Yeah.
Not equal to 12.
Not equal to 12.
Not equal to 12. Okay. You agree?
No. Couldn't it also be smaller since the two smaller sides have to equal the biggest. So if it was 3, wouldn't that work? The third one was 3 plus 5 plus 3.
Uh-oh.
11.
Now you went and screwed everything up.
She's right there.
She is right,
Yeah.
because 3 works.
Yeah.
But you said all numbers greater than 12.
I listed everything that couldn't be.
So would 100 gabillion work?
It would not.
It would not, because 5 plus 7 is not greater than 100 gabillion.
Yes.
So,
I
so,
listed all of the numbers that would not be exactly.
oh, any number greater than 12 would not work.
Yes.
What about -4?
I don't think that's right.
I'm gonna stop talking.
Okay,
Come on, Mike.
Nicole?
Any positive integer that is less than 12.
Any positive integer less than 12? Why integers? Because we love integers and nice pretty answers and we don't like fractions and you got something against 2.5?
No,
Okay, you like 2.5,
no.
but you said integers.
What about 2.5?
Well, I guess then any real numbers that are positive.
Any real number less than
12.
12, -6?
That are positive.
Positive, okay, any real number less than 12. What about 1? Oh. That's a positive number, less than 12. Feel free to jump in on this, you started this one.
Math just does whatever it wants.
I
don't think there's a
understand.
rule.
What do you
I
got?
think it depends on what, if like, it depends like if you're finding like, if those are the shortest angles. I mean sides. Like if those are the shortest sides and you have to do a number that's greater than, you have to do a number that's less than 12.
But I made no stipulation, I just said I have 2 sides.
Yeah, so
How long can the
that's
third side
what you
be?
have to figure out.
Kristen?
Any real number between 3 and 12?
Between 3 and 12.
1.
So let's call the third side x. You're suggesting x be less than 12, can't be equal to 12?
No.
No, because that'd put us in case 3. And greater than, would you say 3? 3, beautiful. What about 2.5?
No. Oh my gosh. Oh, that works.
Huh?
Greater than 2.5.
Greater than 2.5.
No,
Just 2.
Greater than 2?
Yes.
Greater than 2.0.
Would 2.1 work?
Yes.
Okay. What about 2.00000000001?
Yes, that would also.
Yes.
Greater than 2.
It would still be.
That'd be a very
It
strong
would be a
shot.
thing.
It wouldn't be very fun.
But still agrees.
Invisible ink.
Yeah.
All right. So let's see. Let's check to make sure. 1 doesn't work.
No, it does not.
No, because 5 plus 1 is 6, which is not greater than 7. What about 7 though?
5 and 7 is 12.
Good.
That's in my sauce.
And there-
right?
I'm sorry?
That's in my sauce, right?
Right.
That's how school is.
Does that work?
Yeah.
Oh yeah. Okay. Okay.
Yes.
12.5?
No.
No. Okay. So let's make sure you got this now. Suppose we have 3 and 9. We'll call the third side z. What's z? Subash?
Is greater than 6 and less than 12.
Where did those come from?
You got 12, got the 6.
You add 9 plus 3, which is like 12.
Oh.
And you subtract 9 minus
Good. We have 2 simple scenarios here. The first scenario would be that the 2 given sides are your smallest sides, and therefore 12 would be the biggest side. The other case would be that the value that you're looking for is one of the smaller sides, where this is your biggest value. So you add the 2 numbers together to get the big end, you subtract the 2 numbers to get the low end. Okay?
Oh,
Got it?
Perfect sense.
Yes, sir.
So
Yeah.
now I have to do this every time
time we see a triangle.
Eagles.
Wow.
Ah.
Probably more.
Oh, you ain't seen nothing yet.
Oh no.
This is where the fun begins.
Fractions.
Did you just feel like shouting out the word fractions, or?
Okay. Yes. Yeah.
Okay.
By the way, how many scenarios does this problem present? 3 different scenarios. What's one of them? Wait, for discussion purposes, let's call this triangle CAT. Good.
Is the act.
The 3 scenarios come from, obviously 3 scenarios, but you can think of it in a couple different ways. You can think of the 3 scenarios as making one of those sides the smallest. You could think of it as the 3 scenarios making each one of those sides the largest. Or you can think of 3 scenarios where making one of the sides the middle one, but that doesn't make much sense. 1 or 2. Are you raising your hand, or are you just waving your pen around?
Raising hand.
Give me one example.
X minus 1 is less than 2x plus 3, which is less than 5x minus 2.
Nope,
Why not?
because I said so. Yeah. What does the triangle inequality say?
Oh, my bad.
Oh, you want to fix your problem now? All right, go ahead.
2x plus 3 is greater than x minus 1, which is less than 5x minus 2.
Nope.
What?
Come on, Krishna.
Okay, I'm done.
It's okay.
Especially since that's Sue action.
He's right there.
Oh wow.
This is like.
Alright.
I'm just going to let it go because I think you're embarrassed enough as is. You know what I'm saying, Megan? Good. Morgan, what do you got for me?
Would it be x minus 1 plus 2x plus 3 is greater than 5x minus 2?
X minus 1 plus 2x plus 3 is greater than 5x minus 2. Hot diggity.
That works.
The sum of any 2 sides in a triangle have to be greater than the third. And we don't know which one is the smallest side, so we just assume that we have 3 different scenarios. There's the first one. Morgan, give me the second one.
2x plus 3 plus 5x minus 2 is greater than x minus 1.
Good. And the third one.
X minus 1 plus 5x minus 2 is,
Whoa, hold on. X, that's a minus. X minus 1.
is plus 5x minus 2 is greater than 2x plus 3.
Good. Solve each of those, please. Yeah. Solving inequalities are fun.
No.
The best.
No, it's not.
Just as a quick review, what are the rules for solving an inequality? Have fun is one. Good.
Your best.
Do your best. Excellent.
Give it.
Make things unequal because it is an inequality. Excellent. Emily?
Isn't it like when you divide and multiply, you make it negative? What?
Yeah. You got kind of the ideas there. You just didn't put it together into the right puzzle.
Don't the sign.
Well, we heard enough from you today. Ashley.
Wait, do you flip the sign when you multiply or divide by a negative?
Perfect.
Where are you multiplying?
Who said I'm so confused?
Megan Schmicka.
I probably did.
Got it right.
Pronounce it.
Yay! She got a name right.
That name quiz is gonna be really tough.
Oh god.
We're not having
What? You're gonna do it like the end of the semester when everyone's like already.
What?
Everyone thinks that they're grades and stuff. You're just gonna
We're doing that.
Our final should be just names instead of actual
Oh god, yeah. Yes.
Wait, I would totally.
What? Mr. Reedy, it's 3x.
Yes.
What?
Because there's an x and then plus 2x. It's 3x.
Mr. Reedy, you're a math teacher. Be nice.
Excuse me, what?
Stop trying to
X
roast the
plus
teacher.
2x is 3x.
It says 3x.
Yeah, where are you?
It says
Yeah,
2x.
It says.
Three.
Oh, yeah. Yeah.
Oh!
Good, I can fix that.
Come on, Mr.
I know a guy.
I'm not having fun. Grace, are you having fun?
3x plus 2. Ah, that's better. So 2x is boom. Okay.
Yay!
Thank you. 7x plus 1 is less than x minus 1. These colors are freaking me out. 6x is negative 1/3.
Wait, hold on, I actually
No,
got
switch
that.
the sign though.
No.
You don't, because you're dividing by a positive. You just-
But when you divide,
Hold on.
wait, so when do you
Everyone
switch the
needs-
sign?
Alright, everyone calm
When you
down.
multiply or divide by a negative number.
A negative number.
You got it.
I got it.
So 4x is greater than
X is greater
6,
than
so
2.
x is greater than 3/2. Okay, now, I have 3 different possibilities for x. We have to figure out how to put all that together and figure out which one's actually going to work. The easiest way, in my humble opinion, to do that is to use a number line.
Oh, I like those, yeah. Because then you just get to count on them.
Sure.
Let's start all the way to the left. I want x being less than 2.
Okay.
Here's 2. I want x to be less than that, so that's all of that.
Oh, I so missed this.
Changing colors. I want x to be greater than negative 1/3. Here's negative 1/3. I want it to be greater than negative 1/3. And then lastly, changing colors. I want x to be greater than 3/2. After all of that hilarity, where's the answer?
Oh,
Krista?
3/2.
Correct. It's all the values that are all 3 colors. And so that is my answer. I want the numbers less than 2, but greater than 3/2. Okay? How are we doing so far?
Sure.
Good. Enough for me. Next one. The not so fun theorem. Let's see.
You know what it's actually called?
Yeah, it's called the not so fun theorem.
I wish it was.
Yeah.
That'd be an awesome name.
So yesterday we did inequalities in one triangle, so today we have inequalities in 2 triangles.
You know.
Bless you.
You.
I accept your I
A, B, C, D, E. This, by the way, is called the Hinge Theorem. You all know what a hinge is, right?
Yeah.
Good. The thing that opens the door.
Yeah.
The Hinge Theorem has some early requirements, and the requirements are that we have 2 pairs of congruent sides in 2 different triangles, which I have up there. AB is congruent to DE, and BC is congruent to EF. So going back to what we did with congruencies, if I knew that angle B was congruent to angle E, then the triangles would be congruent. We're not dealing with congruent triangles here. We're dealing with the Hinge theorem. So now that we've established that necessary stuff, we then get an inequality statement. And the inequality statement says that angle B is greater than angle E. Okay, that's given information. What comes out of that statement? Or I should say, what do you notice about the triangles? Nothing? What's the relationship between AC and DF?
AC is greater than DF.
Correct. So if you have the original information, or what's called the hypothesis, if you'll recall from logic, if the hypothesis is set up correctly, that you have two pairs of congruent sides, and you know some information either about the third side or of the included pair of angles, so this is, it works either way, also known as being reversible. So in other words, if you know one angle is bigger than the other, then the side opposite has the same relationship. Or if you know that the side opposite has that relationship, then the angles across from them are the same. Now, why is this called the Hinge theorem? Because think of this as being a hinge. You open the door a little bit, the opening is small. You open the door a lot, the opening is bigger. So when I open that door, nothing changes as far as the length of the door or the opening. Okay, small angle, small opening. Big angle, big opening. This distance stays the same, this distance stays the same. Okay? Any problems? Let's see what kind of examples you get out of that. Eight, 6, 12. A, B, C, D. Measure of angle BAC, blank. Measure of angle CAD. Fill in the blank with either greater than, less than, or equal. Okay. What's the first one? First of all, where's the hinge? A, B, C, or D? Back up.
A.
A is the hinge. So the triangle up on top, ABC, and the triangle on the bottom, which one is open larger?
CAD.
Why?
Because the 8 and the 1 they share are equal to each other, and then
Good. There. So let me interrupt you for a second. That's the key here. We've established the hypothesis of the theorem because we have two pairs of congruent sides. We have the two 8s, and then they share the common side of AC. Go ahead.
and then you know that DC is greater than DC, so CAD is greater than BAC.
Or BAC is less than CAD. Good. All right, how about this one? Where's the hinge?
For a triangle RTU, it's at point T, and for triangle STU, it's at point U.
Very good. Two different hinges. This hinge is for this triangle. There's our opening. This hinge is for this triangle. There's the opening. Do we have the hypothesis of the theorem met? Do we have two pairs of congruent sides between the triangles?
Yeah.
Yes. We've got TR congruent to SU, and we've got TU congruent to itself. Which ones open larger? RTU. Because 6 is greater than 5. So if you're going to apply the Hinge theorem, you have to check to make sure that you've got the necessary initial information. Okay? You've got the hypothesis satisfied. 2 congruent sides, 2 pairs of congruent sides between the 2 triangles. And then you need to either look at, are we talking about the opening, one angle being greater than the other and having the opening bigger? Or are we talking about the openings being bigger and looking at the angles across from each other? One last example, and then we're done. Values for x. And notice this says range. There's a whole bunch of different possibilities here. This problem introduces a concept we haven't talked about yet, but it's fairly easy. We'll get to it in a second, unless somebody recognizes it early on. Which one's bigger, the angle on the left or the angle on the right? In other words, is LDM bigger or is NDM bigger? LDM is bigger. So that gives us an inequality statement. What is that inequality statement? Ellen.
The measure of angle LMD.
L N
M
L N L
LMD.
LMD.
My mouse dog.
Yeah.
Is greater than the measure of angle NMD.
Newt mouse dog.
Let's see.
You got the wrong angles.
I did.
Yeah, our hinge is here. Because that's the side that's in.
Oh, okay, so then angle LBM is greater than 9x plus 15.
Good. Solve that.
Yeah.
Okay, what's x?
14.
14.
Less.
It's equal to 14?
Less than.
It's less than 14. Okay, good. Is that a range?
No, no,
It's not.
no.
Wait.
Yeah.
Can x be 0?
No.
Yeah. Can x be,
Oh, yeah.
let's see, can x be negative 1,000?
No.
Why not?
Can be.
It can be.
It can.
It can't be. Why not? I'm sorry?
It would make the angle negative, but
We can't have negative angles? So when we're doing a range problem, most of the time when you're doing a range problem, you need an upper end and you need a lower end. What's the lower end for x? 0. What's 0? X? X can't be 0?
No, x could be -1.
X can be negative 1? Yeah, because negative 1 times 9 is negative 9 plus 15 is 6.
It's like -1.5 or something like that. I don't know.
Well, something like that probably isn't going to get it done. That would be like answering blah, blah, blah on a test. How do I find the other end? Krishna, you were there. What do we know about that angle? Forget about the hinge problem. What do we know about that angle?
can't be negative.
Can't be negative. So what inequality does that give me? No. You're thinking too much. What about it?
0 has to be
How about we do this? All angles that we deal with, remember in the first chapter we said angles have to be positive. And they have to be, for the most part, our angles are less than 180. Don't start packing up yet. 9x plus, is greater than, I should say, negative 15. So x is greater than negative 5/3, which is about 1.5. Thank you, Paul. So now we know that x has to be less than 14 but greater than negative 5/3.